This conference will now be recorded.
Yeah, so one important thing is in DevOps, no matter what knowledge you have, we need to share, we need to discuss. Okay, so that is a practice you have to get it. Okay, so come out of this old mindset, bring it new mindset, start learning, start sharing, and that is how we grow it. So let's not have this training as like, okay, someone is talking and then someone is listening, rather than interactive. You share your ideas, I will share my ideas, and then combine together, and that will be our learnings. Okay, so first question is, what is Docker? I have this question in my mind. So anyone would like to share your knowledge? What do you think? What is a Docker? What is Docker?
Usually, Docker is a place where applications are run inside it with the independencies already available for that, so that you can it'll be whatever your OS may be, it'll be adapting to that. It has certain steps followed, so that's what I
Yeah.
feel Docker is.
Anyone else would like to add on top of it something?
Yeah, like it is an virtualized, and it works like another VM also. Like in the VM, whatever the things we will work, right. So it acts like a VM also, the Docker.
Anyone else?
It usually reduces the task time actually, because all the independencies which are required to download have been downloaded by itself once the
Yeah.
image is pulled.
Yeah. Okay.
Docker is
Yeah.
a technology where it is not like a VM. It actually shares the host resources to the containers, and containers will be having a thin layer of OS where the application runs in the form of image format, which is being generated by using Dockerfiles. And the containers are like something hosting an application, and it is widely used because of serving multiple microservices, thereby dividing the two containers, which offers great security.
So I think you have a very good definition, and it's official definition, I guess. Okay. But actually, I have some issues. I don't understand official definition. So I'll put it in my way. But yeah, your last one, those who stated, I think Ashish.
Yes, I did not stated the official one. I stated what I knew.
Wonderful. Cool. So that is the thing. So that definition is good. Ashish one is good. So certainly it's not a VM. Okay. Other also I heard, probably you can visualize that the thing, but it was not in a right context. Okay. So what I see, let me share mine one also. So Docker is a platform. Someone said first time also, it's a kind of platform. It's like a place, he said, but it's okay, platform. So he's a platform, or you can call it a tool. Okay. Now this is a tool, this is a platform I installed in my desktop, and here it manages container. That's all. It manages container. Now, actually, if I go into little bit detail, sorry, manages storage also well, manage networking also, manages what do you say? Last one, manages image also, image. Okay, these all things right now, but yeah, primarily we'll focus around manages container. Okay, so Docker, simple. If someone will ask you what is Docker, so say, hey, Docker is a platform, Docker is a tool, manage a container. Simple. Now here we'll define something. What is a tool means? So tool means what? See, we are using tools since we human born or derived or avatar, whatever it is on planet. We are using tools. Earlier, we were changing the tools every 500 years. Nowadays, we are changing every year actually. Kind of evolution we have in place. So tool primarily we change. So for saving cost, simple. So you'll say, Rajesh, which way you're talking about the way to change the tool? So see here, it's all about the running application. Okay, running applications. So earlier where we are running application, physical server. After that, where we are running application, virtual server. Then how we are running application inside a container, not in Docker, container. Okay, so here physical server, then virtual server and container. Here physical server who manage, so no one was used to manage, we human only used to manage physical server. Virtual server who manage, hypervisor. All of you understand the hypervisor concept, right?
No, Rajesh.
Hypervisor like a VMware is hypervisor.
I
Hypervisor,
didn't get,
hello.
yeah, I didn't get you, Rajesh.
Hypervisor means VMware. Do you know VMware?
Yeah.
So, so that hypervisor means VMware, VirtualBox, Hyper-V, KVM, Jane. So everyone uses hypervisor only, but products are different. AWS also uses the hypervisor also. Azure also uses the hypervisor. Everyone uses hypervisor. Okay, so hypervisor which manage the virtual server. So who manage the container then? That's where the Docker is coming. So now coming back to the things, is Docker is a tool, is a platform. So what it will do? It will save cost, it will save time, and help us to improve the quality of the software. Quality of the software. Okay, so these are the things. Now you'll say, Rajesh, okay, what way it save cost, what way it save time, and what way it improve the quality of the software, we'll discuss in some. Okay, so coming back to the thing, if I ask someone what is Docker, and if he's saying, hey, Docker is managing your container, then my next question will be, what is container? Do you have the same question? Do you have the same question?
Yes, Rajesh.
Yeah.
Yeah, right.
So here, let's put the context this one first before discussing what the content. Saving cost means, here when we are talking saving cost means when you run application in a container with a Docker, with the help of Docker, then you can save cost RAM, CPU, disk, and operating system cost. Yeah, mind it, I said operating system. So one thing for sure, container is not containing any operating system because we are saving here. So you will be having a question, what exactly it contains then? Someone said container Docker is a VMs, something like that. So again, Docker is not a VM. Why? Because VM is managed by hypervisor, not by Docker. So what is container? We'll discuss this one in some time. But this one here, saving time means, remember yesterday, I mean, one DevOps discussion, I said, you want to run application with a physical server, maybe half day or 1 day, hypervisor 5 minutes, and container 1 second. So here you are saving time, right? 1 second. Remember that. Correct now? How? I'll show you anyways. We are in a session, right? So now the question is, what is container? So guys, I can help you to, get at the very macro level of containers, but the problem is with the timing. Because if I start talking about in detail about the container, then rest of the topics will be missed out. So for that, okay, I will share with you some of my previous recordings of 4 hours or something in which I have discussed about the container. So now the question is, okay, fine. Then what we will discuss? So I will discuss in a simple way what is container, and if you understand, wonderful. If not, then long video you can go for it. Now understanding the container is important for you for knowledge purpose, not for using purpose. Mind it. Okay, you should gain a knowledge, so you should use it, that what is a container. For the using purpose is not required. Okay, so now what is container? So here I can say it's a lightweight. There is one keyword, lightweight applications runtime environment. See, you have to understand each word of it. It's lightweight application runtime environment. What applications I'm having? Let's say I'm having Jenkins application. Think simple, okay? I'm reversing the flow. So this is my application. Oh, by the way, Jenkins application is developed in which programming language? Java. Java. So here, please only read this one. See here. Application runtime environment. So that means maybe if you want to run Jenkins, because a Java-based application, so you need a Tomcat also. After that, you need a Java also, correct? Correct, no?
Yeah, Rajesh.
So this is the runtime environment and Jenkins. So this I understood. Okay. So in a container, I'll have a Java, I'll have Tomcat, I'll have a Jenkins. That's okay. But how it is lightweight? How it is lightweight? So this question is like very, answer is very huge. So I'll put it in a my simple way. Hope you understand. So let's talk about the VM. Okay. In the VM, what you have in the VM virtual machine or your laptop itself, you can, I'm saying VM because we all are using VM nowadays, but you can consider as a laptop also. So in a VM, what kind of things you have? So if you VM, if you see how it is lightweight, let me tell you. In the VM, you have a boot file system and then root file system and then user file system and then application file system. Okay. So now what is a boot file system? So boot file system typically is a kernel. Root file system, can I see that? Let me show you here. Tell me, have you seen this? Have you seen this anywhere?
Yes, Rajesh.
Yes, Rajesh.
So that we call it root file system. We call it root file system. This you find in the Windows also, Linux also. In Windows you find from C drive, D drive and all. C drive program files and all, and Linux you see like this. So this is actually root file system. Okay. User file system means what? Let me show you. You will immediately get it. This is my Rajesh user home, and whatever the files you see, document, download, desktop, this, that, is my user Rajesh user file system. Okay. And finally, you have an application file system. Typically, I install some of my application in C drive. Let me show you. So that is a file system what we have. C drive tools. See, this is a Tomcat. So this is the application file system. So multiple applications will have it like that. So when you say VMs, then it all has this file system actually. You have a boot also, root also, user also, application also. But when we say Docker image, okay, VM image actually here. When you say Docker image, that means here you have only a root, not a boot. So you have a root plus user plus application. Okay, so this is a primary difference. Lightweight, one way if someone say, okay, define lightweight. So you say, hey, Docker image, we do not contain boot. Kernel do not have it in a this one, what is it? Docker image. In the VM image, you have it. So from Docker image, we create a container. From VM image, we create a VM. So VM is lightweight, container is lightweight. You see that? Correct now? All of you? Are you understanding?
Yes, Rajesh, I
Yes.
got you.
Yes, Rajesh.
Now, second thing, then you'll ask Rajesh, okay, fine, maybe I understand. VM, I mean, container Docker image is not having boot. Then boot is needed, no? Boot is needed for running applications. Boot is like a boot label. That is where you have to change your mindset. That is where we have to change your mindset. Look at it. Let me draw one simple picture to understand this. Look at my task manager. This is a task manager. Do you know this one, right? All of you?
Yeah, Rajesh.
Yeah. So let's look at this here. I'll not be able to get into the deep dive into the system level, but just giving you some pointers so you can, if you have a really interest for technology, then you can go inside. See here how many application I'm running. I'm running Chrome, this, that, so many application I'm running it. Now, have you noticed like each applications is getting assigned with the PID and this PID start with a 0. You see that it's incrementing actually. So you will say, Rajesh, where is the in between the number? So that was a temporary process ID created, completed and exited. So it's not there. So here you see the process ID only which is active. Okay, so if you keep running your system, it'll keep growing this process ID. So each application, let's say Chrome, has a process ID, correct now? And status is running. Did you notice actually for each application there is one user needed? Sometimes system, sometimes Rajesh. Have you noticed? And then application CPU and RAM depends on the what exactly we need. So here if I see that for running any application you need a user, correct? Do you see that? You need a CPU, you need a RAM, and you need a PID, right? PID. At least this one you are sure about it, right?
Yeah,
Yes,
Rajesh.
Yeah, Rajesh.
Yeah. So now let's try to understand this flow. You know this, you have studied actually. This is at the hardware layer level. After that, what you do? You install the kernel. Kernel means operating system when I say. Okay. And after that, what happened? You know, after that, the moment you get a kernel, then you get a root file system. This is a root file system. Just now I showed you. For Windows people, C drive or something. And then what happens? You get a PID map. PID map. This is the one here, starting with the 0 always. So you get a PID map, and after that we create a user. There's one user, and there is another user also you can create. Okay, and after that you run application in the user as a user. Correct now? So here, this user, if they want to store some file, so root file systems is common. For this user also OPT, or for this user also OPT. If you talk about in Windows keyword, C drive, C drive. Okay, and PID table will always start with the 0. Maybe this user is PID is let's say 50, So this one will become a 51, and any child process will run 52. This user will become maybe 53, and this may be 54. Any child process of this application 55. This is how it's grow. You see that? You see? Correct now?
Yeah, Rajesh.
So here I'm running multiple tab of Chrome. Chrome, right? This is a Chrome, yeah. So here you see the child process will be there actually for the Chrome. I have to filter it out. See this. See, these are the multiple child process. One parent, I think 124 is a parent, okay? And after that, whatever you see is a child process. Are you able to see?
Yes.
So it's how it is running. So what I'm trying to tell you is for running application, you need hardware, then you need a kernel, and then you need a user. One user, you see that this is one user. Then you need a one user. Here one root file system. Then you need one PID for running application. This is a PID process ID, and then you need one network also. Network so application can be accessible. So these are the important resources we need it. One. So here you see this image. You need this application. So this user, this PID, this root file system, and network also probably you can add one. So these are the resources needed for running applications, correct? Huh? All of you?
Yeah, Rajesh.
So
Yes, Rajesh.
the question was, then you will say, Rajesh, in the Docker image, you have only root plus user plus app. So without a boot, how can you run? So think about it. Simple way. How this user is running without a boot? So they have a root here, and they have a user file system here, an application file system here. So where is a boot? It's here boot, yeah, boot here. So this guy also sharing the boot, this guy also sharing the boot. Okay, so both are sharing the boot file system for running our applications. Okay, so let's not get into too much of detail. Now let's conclude this. So the question was, what is container? So guys, simple way, think simple way. This is something we can call it is a lightweight application runtime environment, and where environment means this one. Okay, environment means this one. Okay, so what is a container? So it's a lightweight application independent environment. This is important. So if I tell you in a simple way, each one of you is container, and would you consider? Yes, this is Rajesh Kumar logged in, right? This is Rajesh Kumar. So Rajesh Kumar is a container actually. Yes, Rajesh Kumar is also container. How? Let's understand this. See here, this is the user. I'll just undo this stuff. This is a user. This is a user. And I'm running application. This is also user. I'm running any applications. But you know what? Network which I'm having here, both the user are sharing. PID, both the user are sharing. Root file system, both the users are sharing. So this 3 is shared by both the user. Okay, that means I'll put it in a more simple way. 2 people will log in, both will work with the same C drive or same OPT. Correct now? Have you seen the 2 users, 2 C drive?
Yes.
No.
2 users, 2 C drive, same system. Have you seen
No.
this?
Yes, it
No.
No, Rajesh.
Yeah. So you have not seen this. So this user is using same C drive here. Same network, same PID, same all these namespaces actually is there, kernel namespaces. This one. So how come I said you are a container? So let's understand what is a container. So think simple. Here, if I run, I'm asking the question. If I run application on 80 port and PID will be 50, do you think this guy run the same application on 80 port, he can be able to run it?
No, Rajesh.
No.
No, Rajesh.
No.
Do you think that 50 PID he will get it ever?
No.
No.
No. So you know that limitation. This is the limitation. But you know what? I will do one thing. Can I create, think simple, okay? Can I create one root file system? Can I means who? Can root can create a root file system one more? Yes, root can create. Can he create network more? Yes, he can create. Can he create a PID map again? Yes, he can create. Can he create a user more? He can create. And can I attach all these resources to this user? Yes, it can be possible. Who? Kernel. Who? Kernel. Again, I'm saying kernel can do that. And can I run applications here? Yes. So this is also user. Here you have a different root file system, different network, and different mount, a different PID, and you see that here. Let's compare this user, and this user. So these 2 users are sharing the root file system and all the resources they are sharing of the system. But this user is not sharing, they have their own resources. Ashish defined, no, they have their own resources, right? This is the resources I was talking about. He was talking. So they have their own resources. So you also have a C drive. Let me duplicate this one. Here also you have a C drive, and here also you have C drive. See that? C drive, OPT, OPT. Are you understanding? All of you?
Yes, Rajesh.
Yeah. So in this case, you know what is container? So this container is this one. This is the one container. And this is the normal user. So container is also user only, but lucky user. We are not lucky user. Why? Because let's say 10 people will log into the machine, no? We all see the same C drive. But you know what? This container, once you log in inside a container, you will see the separate C drive here, separate C drive here, separate C drive in each container. So that's the reason here I said it's lightweight application runtime, but independent environment. So who's doing that? Operating system can't do that actually. Kernel has a capability, but operating system don't allow. Then you will say, Rajesh, are you confusing me? So kernel is having capability, that's okay. And operating system don't allow means what you're talking about? So guys, you need to understand kernel. There's a 2 kernel which right now which is very popular in the market. One is a Windows kernel, one is a Linux kernel. Let's talk about the Linux kernel. So Linux kernel was coded by Linus Torvald. All agree, right?
Yes, yes.
But using the Linux kernel, what has happened? Many organizations has developed multiple operating system. Okay, operating system for the PC, personal computing, such as Fedora, Debian, SUSE, Linux, Amazon Linux, RHEL Linux, CentOS Linux, Ubuntu Linux. These all are, they have developed using the same kernel. Okay, so here operating system don't allow you to create multiple root file system, multiple C drive. Why? They say, hey, I develop an operating system because of user PC, personal computing, not for duplicating all these things. What people will do with the multiple C drive? There's no use of it. What people will do with the multiple network? There's no use of it. What people will do with the multiple PD table? There is no use of it. One PD table is sufficient. See, this one PD table starting with the 0, sufficient. So not required multiple PD table. But actually, this is good for the human being, 1111, something like that, but not good for the running applications in a data center. It's costly. So see here, if you want to, you cannot run two applications. See here, one application you said can run, you only said run 80 port. Now you cannot run this application. That means each host in the data center you have to run only one application. Make sense?
Yes.
But
Yes,
you know
Rajesh.
what? But you know what? If you run application inside a container, you can run as many. See, this is also running on 80 port because of network is here. This is also running on 80 port because of network is here. So each container will get own network, own root file system, own PID, everything you own, powered by kernel. So now operating system will not do that. So who will do that? That is where this guy has came, and this guy has came and say, hey, Salman, where is Salman? Solomon High. This guy. Okay, this guy came and said, hey, let's do one thing. I know that operating system will not allow, but what I will do, I'll write a one software on top of the operating system somewhere here. Okay, and this software will not disturb you anyways, and this software will talk to the kernel and create these resources and these resources, and that this software they call it a Docker, and this we call it a container, and this container is managed by Docker but powered by kernel only. Make sense, guys? All of you in short? All of you?
Yeah, Rajesh.
Yeah.
Yes, Rajesh.
So container is not a VM, container is you, but you are not privileged one. These containers are privileged with the resources. So they can run Apache here also, and as many Apache you can run. Okay, so detailed discussions can happen, but sorry about that. It's a limitation. So next time if someone will ask you, what is Docker? So you simply say, hey, it is a platform where the container is being managed. Okay, that's all. Doing nothing. It's just managing container. You saw the image here. This image. Docker is just like a broker between the kernel and this. Ultimately, kernel will do everything. See, all the capability kernel has it. Docker is just a broking actually, managing the container because of operating system don't want to act like a broker. Okay, so yeah, what is a Docker? This is a platform for what? Managing container. It manages the storage also, networking also, images also. Lots of things are there in Docker. But yeah, just to start. Now next thing, what is a container? So you can say a container is lightweight application runtime environment, independent environment, and powered by kernel. Okay, kernel in itself you have a multiple component. Okay, kernel namespaces, kernel C groups, kernel capabilities. I don't want to complicate it, but yeah, this I'll give you the some pointer in your mind. Docker architecture, just a minute. So you will have it actually. Many discussions can happen, but right now you don't need it. See here, look at this here. Kernel has a C groups, namespaces, SC Linux capabilities, all these things. and using the Docker is using the kernel capability to manage the container. Okay, so that is stuff. So yeah, so container is lightweight application runtime environment powered by kernel, managed by Docker. Managed by Docker. Understood, all of you? So now they will.
Yes, Rajesh.
Rajesh.
Now one line Ashish shared, no, own resources. If someone will say, hey, what resources you are talking about? So you say, hey, resources means to run any application, you required some sort of namespaces, C groups, capabilities, and stuff like that from the kernel, such as root user namespaces, root namespaces, PID namespaces, network namespaces, and all these things. These are the namespaces basically. Okay, so these are the resources we required. These are the system resources, kernel resources for application runtime. So that is the resources which kernels gets it. But here each resources, each kernel, each container getting each resources, one resources each. Make sense, guys, all of you?
Yes, Rajesh.
Okay, so now we understood what is Docker and what is container. Okay, so container is not a VM. Container do not contain operating system. Container is you. You contain the operating system? No. So all the container uses the same host capabilities for the root file system. So see here, here you have a here you have a application file system and root file system in each container. Here you have a boot file system. Okay, so common boot file system. Okay, so now let's get into the some demo side. So how to install container? How to install Docker? Sorry. So this I will do in front of you. So let's use this in AWS. So let me create one instance. I'll go for Ubuntu. Will that be okay for everyone?
Yeah.
Here.
CentOS would be much better, I guess.
Okay, no problem. CentOS 7. Okay.
Yeah.
So deprecated, by the way. We have to stop using. So I'll go for 2 CPU, 8 GB RAM. This is sufficient for all of us. Okay, so I'll, if possible, sometime possible, end of the day, I'll give you some lab also. So this is the machine, okay, and this is the IP address. Now I have a keys actually. I'll give you the keys, ppk5, which you can use with the putty. So go to the putty. And this is the IP address. And this is the key. I'll share with you key Rajesh-ppk. Okay, so now I got the access to system. I'll just improve the view. Username is CentOS. Okay, remember key I have already. I'll become a root today, not complicating too much. So become a root. And how to install it? So guys, anything as such, when you want some resources, you can go to DevOps School blog here, okay, and search for that topic. For example, Docker install. So I try my best to keep the one tutorial for each topic. You will find a lot of resources here. So here Docker installation and configurations. Okay. Here you have a 3 method to install the Docker. There's 1, 2, and 3. This is the shortest. So I'm installing the Docker. Any questions anyone have so far?
No, Raj.
Okay. Okay. By the way, guys, because of many constraints, I'm not using slides and all because it will waste lots of time. But yeah, all the slides, if you want to refer it, go and get it here. All this topic you have it. Okay. Some of the slides you can find on the slide also. So comfortable with this platform, it's growing platform. A lot of resources you'll have it. Sure. But this is the main locations. My old slides, if you want to access it, so it can be available at this location. It's a single example. Okay, so in the recordings, you'll have all this URL. Just remind me if you want in the group also. I'll send it to you. Okay, so all the slides, let's say Docker, right? Here it is Docker slides here. So these are the Docker slides you have. Other topics also, let's say yesterday, which were the topic which you covered last day? Terraform.
Terraform.
So Terraform slides. Okay, so yeah. So now is Docker got installed now. Let me go back to the demo. And I'm going to enable it. So we don't need tomorrow. Maybe. Now after that, we're going to start this Docker. Okay, so Docker is installed. You have it. You installed it. How do I verify Docker installation? Simple. You say Docker, enter. Yes, it got installed. Docker version, if you want to see here, there's a Docker engine, community version which we have it. Docker engine. This is the client, and this is so Docker installed actually. Now after that, what I need to do? What I need to do? So we call it container life cycle. Okay, container life cycle. That means life cycle means starting to end. VM life cycle also you can call it. So let's talk about the VM life cycle, and then we'll talk about the container life cycle. So tell me, what is a VM life cycle which you have been working pretty long?
No idea.
VMware life cycle means question.
Create VM, start VM.
Using VirtualBox we can do.
Yeah. So you create a VM, then start the VM. If it is started, you stop the VM. If you stop, you start again. If it started, you restart again. If it's running, then you can pause also. Okay. You can pause also. You can unpause after that also. Okay. And then you can kill the VM also, and you can remove the VM. This is the other life cycle. So these are the things you do with the VM actually every day if you are using. So container is having same one. You can create a container, you can start the container, you can stop the container, you can restart the container, you can pause the container, you cannot pause the container, you can kill the container, you can remove the container. So these are the things you can do with the containers also. So now next question you will have, okay, Docker components. So this is important topic which we need to understand. So in a Docker component, first thing is Docker itself. Need to install. Did I install? Yes. So Docker, actually, you know what, guys? Docker, everyone says the Docker, but actually we didn't mean to say Docker actually. Means everyone is saying Docker, Docker, Docker. Docker is not having any product as such. Docker is not a product. Yes, it's not a good right name actually. Docker is not a product. It's a company name. They have multiple products. One of the product they have is Docker engine, and that was their first product. And you know, this product only we are learning actually. This product only we are learning. We see here. But because it was their first product, we all say Docker, 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 Docker. They have a Swarm also, they have Registry also, they have Enterprise also, they have DTT also, Docker Cloud is there. So many things they have. Are you understanding, all of you?
Yes, Rajesh.
Yes.
Yeah. So Docker component means Docker engine, which we installed it. After that, you need a Docker image actually. See, you create a VM using image, right? So for that, for the container also you need an image. So Docker image. So Docker image, what is image? So Docker image is like a VM image. So here I showed you know difference between the DM's image and Docker image. Look at this here. So Docker image will not have operating system. See here. This I said VM image. What if someone will ask you, tell me what is the difference between the VM image and Docker image? So simply technical differences you can say in the Docker image and the VM image, it contains the boot file system, which is lacking in the Docker image. So Docker image, we have only root plus user plus app. Make sense, guys, all of you?
Yeah, Rajesh.
So example, let me give
Yes,
you.
Raj.
Let me give you example. Here, when is a root Ubuntu plus user root plus some app ls. Yes, Ubuntu is not operating system in the container world. I repeat, in a container world, Ubuntu is not operating system. But here what they do, bootfs kernel, Linux kernel, then Ubuntu, then root, and then user. So this they call it Ubuntu operating system, but actually in the container world, you have to change your mindset. Ubuntu is a root file system actually. So kernel is a Linux kernel is a boot file system, which is lacking in the Docker image. So next time, what will there? Here it can be CentOS plus user, let's say Apache, and here application can be Java plus Tomcat plus app. So this will contain the Docker image. You can contain only CentOS also. Okay, only CentOS also, or CentOS and Apache. It can be in any image, but starting with the root file system. So Ubuntu, CentOS, Fedora, Debian, these all are root file system. So this, if you want to image only of this, so this is called base image. Okay, base image. So here, let me show you where do you get an image. So third concept is Docker registry. Registry. So registry will have a repository. Okay, repository, and repository will have a version of file system. Which file system? These are the file system. So here where we see the registry, so we have a hub.docker.com, which is a registry. Guys, request you to avoid my typo because I'm just writing everything, so might make mistakes. So this is the hub.docker.com. This is the registry, okay? And here you will find repository. See Ubuntu. So don't get confused. Ubuntu is operating system. Let me install it. This is not operating system. What exactly that is? Root file system. Correct now?
Root.
All of you are getting?
Good.
Yeah. But when you say MySQL,
Yes.
so MySQL will have a root plus XYZ. Okay, including MySQL. Got it? So these are the image. How many images you have? Look at this number. 1 lakh image. So hub.docker.com is a registry. There you get repository. Repository has a version of file system. Which version of file system? Root, user, app 1, app 2, app 3, like this. Are you understanding what I'm trying to say, all of you?
Yeah, Rajesh.
Yes, right.
So here, this
Yes,
guy,
Rajesh.
Ubuntu, so for registry, Ubuntu is a repository which contain the version of file system for Ubuntu, like that. Understand this. So in that case, let me ask you one thing. Have you used the GitHub?
Yes, Rajesh.
So what is GitHub? GitHub is repository or registry?
Repository.
Repository.
Think, guys, need a break. Think and tell me. Don't jump to the conclusion.
Registry.
GitHub is registry or repository?
Registry.
Yes,
Registry containing repositories.
correct. GitHub is a registry which is contain the repository. You can create as many repository on the GitHub. I have hundreds of repository. You see that all my source code is lying. I don't store anything in my laptop because everything in a public domain, everyone can access it. These are all my repositories. These are, and repository contain what? Version of file system. These are the versions only, right? These are the file system, files and folders, and versioning is stored in the and that. Correct now? The same way is a Docker Hub also. So Docker image is also file system, no? You see root file system, user file system, application file system. Make sense, guys? Yeah. So this is the first component of Docker, which you need to install. Then you need to have a Docker image from where you can get it, Docker registry. And the last component is Docker container. So what is a container? So the moment, please, this is I'm writing in detail. And the moment you run Docker image, see here, I said run. I said run. So the moment you run Docker image, what will happen? You know, the flow. One root file system created by using image by Docker with the help of kernel. This is by it applied everywhere. Okay. By apply. How? Let me put it in this way. So this is the Docker client. This is human. Human send the request to the client. Docker client send the request to Docker server. Okay, this is the server which I showed you. See here, server. And server send that to request to the container D. Container D, question mark, what is container D? We will figure it out. Kernel, and this is the whole communications. So client send this to server send to the container D send to the kernel, and then container get created. So here what happens, the moment you run the Docker image, one root file system get created using image, one network get created, okay, and one PID got created, one PID get created, one container I'm talking about, okay, and one user get created, okay, created, and then attach this user with network, root file system, and plus PID. That is all done by kernel, okay, is equal to one container. Understood, all of you?
Yeah, Rajesh.
So this
Yes,
is a
Rajesh.
component. Okay, so no more jargon, guys. You lose the interest in topic. But yeah, those who are having curiosity to know more about it and all stuff like that, you can check some of my videos on YouTube and, uh, and learn from them and stuff like that. Okay, so let's get started. Now demo time, guys. First thing I need an image. Okay, so which image I will go for it? So guys, I'll go for there's some noise coming from someone. Can you please mute yourself? I don't know from where it is coming. I think it's coming from Rupa.
Yeah, my God.
Yeah. Okay guys. So what to do? Demo time guys. So what is the image I'm going to use it? So image we decided let's go for the HTTPD web applications. Okay, so official image. So how do I pull it? So yeah, let me show you some wrap up command. So Docker installed, yes, installed. Docker installed. Docker version, here it is. Docker info, here it is. Now I am running little fast, but you will run slow. Read it every fields. One more thing, many of these fields you will not understand, but you have to read it. Why? Because human mind is designed in a such way. Today you will not remember it, but just you look at it each and every option. Tomorrow you can correlate when the time comes. Okay. So Docker info has a many things. How many containers are running? Docker PS. How many are containers are not running, including A for all? How many images you have? Docker images. That's all. These are the questions. These are the commands you should know. So how do we download the image? Docker pull HTTPD. We all are working with these images. I downloaded this image. How many images I'm having right now in local? HTTPD. Now after that, can I follow this rule? Yes. So how do I do that? So I'm going to create a container Docker create. Remember create. Look at this. Create what container from HTTPD. I should give the name also, right? Because we all are having so many people in this session. I don't want to fight with you. My name, my nickname is Raj. So here, name Raj1. Enter. How many containers? It's not running. All you see here, container ID. So each container you create, you get a ID, unique ID from image. Container is running with this created by and status created Raj1. So can I create one more container? Raj2. This is two my containers. How much time it took to create a container? I told you multiple times. 1 second. So what to do after that? I'm going to start the container. So Docker start. You can use the container ID also, name also. I repeat, ID and name, both you can use it. So container start Raj2, and the spelling mistake, guys. So Docker start Raj2, and here you see, guys, one is created, one is running up. Raj2 is running. Can I stop the Raj2? See here. So when you stop any container, what you see? Exited. Okay, can I start it one more time? See here, exited container, you can start it one more time. See here, can I restart it? See here, and see here, up 2 seconds. Are you getting me what I'm trying to do?
Right.
Yeah.
Yes.
So this is the, can we pause container? Paused. See paused status. Can we unpause? Now, what happens in a pause? What happens in unpause? I will ask you for submitting the proposal for this. I mean, assignment here. So, can we kill this? What is the difference between stop and kill? I want you to find out real. See, try to find out the answer by doing it, not by reading few lines of Google copy paste, and that will not help you. See, kill that container. Can I remove it? Remove RM, and you see here workflow life cycle is completed of the container. Create, start, stop, start, restart, pause, unpause, and all these commands are just run in front of you in that case here. So tell me, did you really find any difficulties working with the container?
No, Rajesh. It was easy.
Yeah. So now the question is, okay, you will say, Rajesh, we created a container, that's okay. But how do we use it, that container? That is a question, right? How do we use it? So that is a one topic I would like to talk about it. How do we use it? So let's ask in a simple way. Simply we complicate this and that. Tell me one thing, you set up a laptop or you set up a VM. How do you use it? Tell me.
Switch on.
No, using it, I'm saying. Starting
Yes,
is done. Start.
in virtual box start and stop option will be there, so thereby
Sir,
it
sir, sorry to stop you. I said starting is done. This VM is running healthy. It's running. So what to do after that? What to do after that?
Open the applications which are required to work on.
making it accessible through network.
Enter into the
Sir,
container.
see, go inside a VM. Don't you go inside a VM? Or do whatever you want, I don't care. Correct? And access from outside. So for this you need a network, correct? No? You go inside a VM. How do you go inside a VM? What is the mode we use it? Shell, right? In Linux,
Yes.
which shell you guys are using?
Bash.
And Windows?
No,
PowerShell.
Windows PowerShell, right? Without a shell, how can you work actually? See, you have to sacrifice the console actually. I know that we got used to it, Windows console or Ubuntu console, but we have, sorry, I mean Linux console also, Ubuntu also. I mean all the desktop version of Linux coming with the console actually. You need to sacrifice actually. You need to work with a shell, PowerShell, Windows shell, Linux shell, and all. Okay, so coming back to things. So how, if you have a VMs running, okay, so either you go inside a VM or you access from outside. If VM already has application running, you access from outside. And if you want to do some changes in the VM, then you go through the shell and do some changes. Correct? No? Agree?
Yes.
All of you?
Yeah, right.
Yes.
Yeah, right.
Yes,
Yeah.
we agree.
So container is also application runtime environment. No, why you are giving so much special attention to the container? So we'll go inside a container and then access the container from outside. Now the question is how. So guys, there is one exec command. Exec command, you know what, is very powerful. Exec command, you can use it to run any commands inside a container. So do I have any container? Let me check. No, I don't have any container. It's there created. So let me start this container. Docker start running. So now this container is running. You see that here. This is running 4 seconds. So can I see? So exec command will execute. Please hear me out clearly. Exec command will execute. Exec command will execute commands inside a container. Yeah. So see a Docker exec. Which container? You can use the name of the container also, ls. See where it got executed. Not in your machine. Not in your machine. See here. It got executed in
Shell.
shell, not shell, not shell. Inside a container. Okay, you are running inside a container. So let me see df. See, this is not a machine. This is of container. df. This is your server. See, next one is of your server, base machine. This is inside of container. I told you, remember that in the container also you get a root file system. Correct now?
Yes.
Yes.
Yes, Rajesh.
Don't forget. Container will start also the PID with 0 if you go inside. I'll show you that. Just give me 2 seconds. Okay. Du will not be there. Is there? Yeah. This is inside a container. Okay. And this is your host machine. You want to see that? ls root. And you want to see that host machine? ls root. See here. Matching. Both has a different root file system. Different, but root file system. So exec command is very powerful, guys. You should use it. But the question was how to go inside a container. So here what you are doing, this command, you are using it for getting inside it. So what? So here you are saying, hey, I want to interact rather than running and exiting. Okay, you want to interact. Who are you? I'm a human being. Human being use what? Shell. So bash shell, right? Where are you right now?
Inside containers.
Inside a container, and you do whatever you want. Don't treat containers separately. As you've been working with the Linux, you can work with the container inside also. Okay. See here. This is inside a container. Do whatever you want. PS command is not there inside a container. You can install it. It's a one apt get. Apt is working. Yeah. You can install it. Apt get install x1 number of tools and all whatever is not there. And update. Are you understanding? Don't give up so much of importance to container. Container is you. Whatever you do, you can do inside a container also. Make sense, guys, all of you?
Yeah.
Yes, Rajesh. Yeah, Rajesh.
Yes.
So I got it out of it container. So here you see still running. So whatever environment, see independent environment, you saw that. Now why I said this lightweight independent environment. So independent application runtime environment. Where's the container? Somewhere top. See here. And all that. Okay, so each container. So now, okay, fine, I understood that. Okay, I can go inside a container, but how can I access the container from outside? Get IP address. Each container we have IP address. So how do I get it? Inspect command and container ID. I will read every fields, whether I understand or not understand, but I will read it. Why? Because for next session, I mean advanced understanding. This is the IP address. Can you curl Apache? It's Apache container. Okay. See, this is Apache. Accessible. 80 port number. Understood, all of you?
Yeah.
So yeah, these are the commands I run in order to display this one. So far so good, right, all of you?
Yeah.
Yeah, Rajesh.
Yeah, Rajesh.
Guys, you know what? I got little bored using so many commands. So can we minimize the commands? Can we do that? So yes, we can do that. So there's one command which is called run. Most of us will use it actually. Most of us. So what is a run? So run has a multiple behavior actually, I must tell you. So run will pull, after that will create, after that will start, and after that will attach. So tell me which one you do not understand. Pull you understand?
Yes, Rajesh.
Create and start you understand?
Done.
Yeah.
What is attach? So attach means attaching to the console. So let's say there's one container running here. Okay. So you want to attach to this console. What is happening here? I want to know HTTP foreground is running your container. You want to attach to that session, so the console. So how do you do that? Docker attach. Many people in the past they said, Rajesh, I got stuck, system got hanged. Actually, no, it's not hanged. You attach to the session of HTTP foreground, and there's nothing is happening, so you are seeing nothing. Can I show you that from the other duplicate session? CentOS sudo -s. What was the curl statement? I hit one. Okay, see one line. So basically, you attach to the Apache session, you can troubleshoot. Are you understanding, all of you?
No, I didn't
Yeah,
get you,
Rajesh.
Rajesh.
Attach means seeing the live session of the executable, which is called fork, which is running your applications.
Oh.
See, sometime I think you have experience. I'll tell you. Sometime when you run application, you lose the console and you start seeing that floated with the logs, right? So what do? You run application in the background. Have you done it? Have you done that?
Yes. Yes, yes.
Yeah. So same thing. So you floated with the I did attach. So I'm floating with this. That's
Oh,
all.
okay, I got you.
Yeah. So this is something. So attach means you attaching to the session of the container PID1. Technically, I can say PID1, but I don't want to add too many confusion actually right now in the discussion because I'm not having a detailed session. No? So you attach to the session of the this executable which is of this container. Simple, but technically it's a PID1 actually. Okay. So now you understand attach. So what was the question actually? So guys, you know what? If you run any image, then these four actions will happen. Let me show you. Let me kill this container. The moment I will control C, this container will be killed. You see here, because of some reason. I'll talk about little bit later. So here Docker run HTTPD. Okay, and here naming it Rajesh Raj3. See here, what happened? What happened? I attach because I run, right? Run means it will create a new container, start the container, attach to that. The same thing has happened. Got it? All of you?
Yes.
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 So now you'll say, Rajesh, I don't want to attach. I'm wasting time and I don't want to see the logs. So detached, simple. Do not attach. So you pull, create, start, but do not attach. So can we do that? The Docker run -d and httpd. See here, running 3, 4, 5, 6 container, and you see so many containers running. So many Apache is running. Just have you got this kind of experience like you can run any application within a second? This is the container. This is the world of container.
Hmm. Rajesh, one small doubt. Because of
Yeah.
it running on the same port, will it in future will do we get any alterations like if there is a container and we are running Jenkins for in case and it is running on a port 8080. It is the default port for Jenkins and we are
Yeah.
running 8080 on the same port. We are using something else like Kubernetes.
See,
Uh,
each container is running inside at 80 port. Okay.
Yeah.
So if you want to change the port, see inside each container you are running at the 80 port. Sorry. So sorry. So if you want to change the port, what should you do? Change the image, because image is the source of your port. No, everything you have in the image itself. So how do you write a better image? I'll not be able to cover now, but if you want, I can cover that also. So you can change the image port actually. Where to change? Let me show you the place. Go to the latest one, Dockerfile, and you see the somewhere the port will be 80. Where is that? Change this here. And by the way, not only this one, you have to change application also. I'll tell you in a simple way. Let me ask you. You run Tomcat in your laptop, and if I ask you, hey, change the port, where do you go? Where do you go? Changing the port. Tell me quickly.
Mm.
You will go to the
I'll,
Tomcat configuration, no?
yes, I'll go into the Tomcat configuration and I'll check wherever the port is assigned to 80. I'll change it to
8080, yeah. So same
yeah.
way, in the file which you are pushing, I mean, this is the Docker file. I don't know how you know that, but yeah, the file where you are pushing that, change the port, the default port to 8080 to something else, and it will be changed. Here also you have to change two places as per this. Okay, so source you change, here also you change. Runtime also change. Okay, so now guys, this is the world of containers what we have. So let me, these are the command I run. So yeah, run you understand, run -d. Run, we all the time use the run and create a container. Any questions guys so far?
No, Raj.
No, Rajesh.
Okay, so now guys, I don't have a patience to clean all this container, you know. So I'll use magic commands, and that command docker stop and remove all containers, and the magic command is, where is the stop command? Here it is. So stopping all the containers and removing all the containers. Done. So in one go all the container has gone. So this is the what Docker. So let's recap the stuff. So we so far what we discussed is what is Docker. Then we used what is container. Then we use how to install Docker. After that we use component. We learned components of Docker. Then we started playing with the container lifecycle. Then we created a container, follow the lifecycle. And after that, we started using the container, accessing the container, and so on. Did you understand now Docker and container, all of you?
Yes, Rajesh.
Okay.
Yes, right.
So now,